Thank you.
Today I will present our paper named Implementation of a New Voting System based on blockchain using ECDSA, like elliptic curve digital signature algorithm with blind signatures. First, I would like to talk about the motivation, our goals, and the problem that we defined within this research. The main idea behind the motivation for the research comes from the replacement of centralized systems with another system with decentralized systems, because there has been an example in the history where the records that were stored in the records that were stored were changed by the centralized centralized organization, and that's why the idea of decentralized system came on the scene. There are many ways how to describe the and use in practice the decentralized systems, but one of the examples that we chose in this research was the electronic voting system. The difference between the centralized and decentralized systems is that the centralized systems have one main organization that controls the whole flow of the communication, and everything goes to and out from this organization or like node in the chain. But on the other side, we have the decentralized systems where this central node is omitted, so all nodes can communicate between themselves. And that's why we had the idea for building a new electronic voting system based on blockchain. There are already existing ones like Agora, iVote, and many others that are built from companies, and those are like already in practice. But in our new electronic voting system, we decided to use a specific algorithm, the elliptic curve digital signature algorithm with blind signatures, which will be defined in the later presentation. We had few phases in the development of the new system. So first, we search for like how to implement those two topics, because these two principles cannot be combined together, but they need some modifications in order to make it work. So in the next phase, we did the programming part. So we programmed the whole system. Then we also decided to go for but that's not like part of the paper, but part of the whole research. So we also did the cryptanalysis of the system. First, we described some attacks that can happen and are based on mathematical basis, and then how those attacks will affect our system. Just shortly, the main terms that will be used into the research and the whole area. So first we have the cryptology, which is a discipline for the hidden word, and the cryptology has two parts, as I mentioned. The cryptography, where we did like the encoding and choosing like a secure algorithm how to do so, and the cryptanalysis, where we did the other part, so the attacks that can happen in order to so they can break the cipher. The original message that is sent in the communication before the encryption, it's noted with M, and the output of the encryption, like the cipher message, is noted with C. The process that turns the original into the cipher message is called encryption, and vice versa. The process that turns the cipher message into the original message is called decryption. There are two cryptography types, and one is symmetric cryptography. So as its name says, there is only one key that is used on both sides. So like we have a private key and both parties use the same private key, and on the other hand, we have the asymmetric cryptography that uses two keys, a public and a private key. So we use the public key to do the encoding, and then on the other side, the receiver does the decoding with the private key. As part of symmetric cryptography, there are two ciphers, stream cipher and block stream ciphers and block ciphers. The difference between this is that the stream cipher, so we do like the encoding bit by bit, so and then the whole message is sent, and on the in the block ciphers we have the a separation into blocks with the same length, and we do the encryption on block based. So the blockchain technology is, as its name says, a chain that is connected with more elements, or they are called blocks in the chain, and that can communicate in real time and can send and receive data without the authorization of another node or organization. The need for the blockchain technology comes directly from the examples from the history where the centralized node changed some of the receipts that were stored, and the idea is that with the omission of this central and node, the nodes can like have the same priority in the chain, not like just one that gets and receives everything, but everything is now related to the node itself. And as I mentioned, the benefits of the decentralized systems in general are the real-time communication and the all the nodes now have the same privileges and priority. There are four elements of the blockchain technology. First, we have the peer-to-peer chain, which is the chain itself. Then we have the cryptography, which is the algorithm that is used in order to do the encoding and the whole process in the blockchain. We have then the consensus algorithm. So before one block is joined into the chain, that block needs to solve some issue in order to get into the chain. This is usually some mathematical equation that needs to be solved, and if the new block solves it correctly, then it can get into the chain. And based on that, we have the reward or punishment. In our research, we use that specific ECDSA algorithm as a consensus algorithm. So the advantages and disadvantages of the blockchain technology: we have increased security, which is based directly on the chosen cryptography method, increased transparency, tracking data in real time, increased efficiency and speed, automatization, increased participation of the nodes in the chain. And the disadvantages of the blockchain technology are that there are a small number of professionals in this area because this is quite modern and new. We have scalability problems, which are in general for all blockchain and electronic voting system, and we don't have universal standards that are defined because this comes directly from the small number of professionals. So people are like, in other words, writing different standardized code. For the purpose of this research, we built the application in two parts: the front end and the back end. So on the front end, we use Angular, TypeScript with RxJS, and Bootstrap and Sass for the design. And on the backend, we use Java with Spring Boot and the relational database H2 with SQL. The architecture of the system So the front end, that's the left part of the slide. So we have the principle of lazy loading, which means that as we navigate to the application, we only load the modules that we require for those for that page, not like the all modules that are loaded all the time. And in order to maintain the code like in few months or years later, we decided to use the Angular's best practices and that separation into components, models, pages, views, and services based on the purpose they do. And we also have reusable components, and that's the transaction table, which we will see on the screens later. On the backend side, we have like a relation in order to connect the front end and backend. So for every service, there is a controller, and for every interface, there is an entity and a table in the database. Just shortly to some screens of the application. So we have the login and registration. We have two roles in the application. We have the admin and the user. So the admin is created when the application starts, and there is only one admin, and the user has to first do the registration form, and then he can when he creates a password, he can logs in into the system. This is the admin panel. So the admin panel has like the general CRUD operations for adding, editing, and deleting, and sync all candidates. And also the admin can see the frequency per or number of votes per candidate, which means that with the given select, he can select the wanted candidate and see the number of votes for it, which means that the admin only sees the number of votes, but nothing which candidate voted for which user voted for which candidate, and that's the purpose of the whole electronic voting system, or obtaining the anonymity. The user panel looks similar with the table as the admin panel, but the user sees the candidates, cannot do anything to them, just chose the vote button for the wanted candidate. And here we can see how the block is built itself, which means as the user votes, successfully votes, the new block, the new vote is added to the blockchain itself. And if we click on every blockchain, we can see the transactions inside block, and can see also if the transaction was valid or not. The idea of this blockchain visual representation is because there will be also non-technical people voting while using the application. So how could you visually show to the user that what's the benefit of the blockchain technology and why it is used for the electronic voting? So that's why we decided to show the chain itself, so the user can see like how many votes are now, but only how the chain is built, and like when it's done the voting, but nothing which candidate, which user voted for which candidate. After the user votes, he can see the blockchain adds to the chain, and it's connected to the previous block, and message "thank you for voting." Even if the user now logs out and logs in again, then he would still see this screen because there is no way how to change the vote. So we decided to make the UI a little bit more practical. So when we click on vote in this table, the user is navigated to the he gets a model where he confirms a candidate that he chose, and this is because someone can by mistake like click on some candidate or change it while the electronic voting process, and that's why on the second step we also displayed like selected candidates, so he can always see the desired candidate. And first part is the low picture where the user sends the transaction to from his address to the electronic voting system, so the admin panel, and when he does, he can see the table, the reusable component, also here if it's valid or not. And before he signs vote and confirms the voting, he must enter his private key. Once the private key is added, the sign up and confirm button is enabled, and when we click on this button, when the user clicks on this button, then in the background the whole electronic curved digital signature algorithm with blind signatures is implemented. Just a little overview that we also did the system analysis using Lighthouse, but the performances for the registration and login are quite okay, but for the blockchain itself, the performances are quite low because of the equations, the complex equations that are being executed on the backend. So the architecture of the digital signature or the electric curve digital signature module is that we have like first we have like a point which has the x and y coordinates on the curve. We have the curve itself. The class math handles the mathematical operations like multiplication with scalar multiplication, or all the math operations. We have then the public and the private key that uses the private key is the one that was entered in the input before, and we have the class elliptic curve digital signature that like holds the whole algorithm, and last we have the signature, which also has two parts that are created within this algorithm. So as I mentioned, the elliptic curve digital signature algorithm with blind signatures does not fit together, but they require the modified Pyler crypto system. And for the because the time is limited, we omitted the equations that are used for this. But what is more, besides the general idea for with blind signatures, we also used the interactive zero knowledge proof in order to make sure that the signature is built correctly. So we have the elliptic curve digital signature algorithm with blind signatures with modified Pyler crypto system, and additionally within this algorithm we use the interactive zero knowledge proof, and in some way the system and the user communicate like communicate and exchange question and answers for this protocol, so they can make sure that the signature is built correctly. We also tried using the non-interactive zero knowledge proof, but so that's instead of like communication between the two parties, to use a hash function, which is which is like really faster than before. But the main problem is the possibility of birthday attack, because then if the hash function is duplicated, then the whole process of voting will be insecure. Finally, we did the comparison to other systems for electronic voting. All systems that were chosen are based on the blockchain technology, which have some different characteristics for comparison, and we separated the comparison into two parts: systems that are built from individuals and systems that are built from companies. The systems that are built from companies more or less have all the characteristics that are required for the voting fulfilled, because they are already systems that are many years in practice, and with time it gets better. So that's why we decided to compare our system with systems built from individuals because it makes more sense. And the results from this were so the anonymity is fulfilled with blind signatures with elliptic curve digital signature algorithm. We have revision because we have supervision by a third party, the admin. The voter verifiability is not fulfilled because we don't have like a list of expected voters, and we do not. I mean, yes, there is, but we are not comparing if like all of the voters that were expected also voted, but maybe this is a point for future work. Accuracy, we are not comparing if it's valid or invalid. I mean, if it's invalid, then the block will not be it. That's handled on the backend, but there is no like statistics on the admin panel that we can see the number of valid and invalid votes. Availability is fulfilled. That's the idea of the whole electronic vote. One of the points of the electronic voting system. The users can vote from any place and time. Scalability. So we need a third party that so the system can be adjusted, and this is also the problem for all electronic voting systems, even for the systems that use that are built from companies. And last, we decided to do something that is not on the other system, and that's the blockchain that I showed in the visual representation of the blockchain, because we believe that with this the main idea behind the blockchain technology, we are showing that to the users, the advantages of it, and it's like accessible to the users without breaking the anonymity. The problems with this solution with a chain on the screen was the DOM tree that was overloaded, and we wanted to we proposed two solutions for that pagination, like so only the number of blocks in the screen is limited, or a filter. And that's why we for this point of the research we say that the system is usable only in smaller organizations, but we have like the fast operations to the database, which is good, but complex operations on the computations of the algorithm, and that's what also the Lighthouse performances showed. Conclusion, so the system security is at high level. The elliptic curve digital signature algorithm with blind signatures work using a modified failure crypto system plus an interactive zero knowledge protocol. Scalability in electronic voting systems in general is a major downside. The block grid view makes the system unique, and the choice of technologies proved to be satisfactory. I mean, in the development part, there were not some issues that came from this point. And thank you for your attention. I hope you enjoyed our presentation.